Alright, so this week we'll take a look at section 2.2. We'll split it into 3 parts, and then on Thursday we'll have a review day. So it'll be kind of a good time if you want to make your reference sheet, ask me questions about what's on the test, stuff like that. Alright, so we're going to use this circle, okay, this diagram pretty much all week. Alright, so it's just a circle, and I drew axes right through the middle of it. And I labeled some of the angles going around the circle. So remember, positive angles go counterclockwise, starting with 0 degrees on the positive x-axis, and then 90 is at the top, 180 on the left, 270 at the bottom. Now, that's a unit circle. Okay, unit circle, I think we mentioned it last week. All that means is the radius on that circle is 1. Okay, and I didn't label every radii in the circle, but I labeled 1. Okay, any questions on that picture? All right. So, this is kind of the idea with unit circle trig. Okay. Every angle on that circle, or at least special ones that we're going to work with, can be represented as a coordinate. Okay. That's basically the goal with unit circle trig, to figure out a coordinate. Some coordinates are easier than others. Okay, but all the angles that we're going to work with can be represented as a coordinate on this circle. So, like, let's just say, I'm going to pick something here. Right? So let's say let me do a different color. Right. So you started rotating around the circle, you stopped here. There's an angle right there. Okay, we don't know what it is. Okay. But to get from the origin, you'd go over this much and up that much. However much you go over to the right, that's your x value. And however much you had to go up, that would be your y value. And together, those x and y values are the coordinates for this point, which is on the side of that angle. Okay? So that's what we have to figure out, coordinates of that point. So let's label the coordinates for 0, 90, 180, and 270. Okay, those are easier ones because they're all on an axis. Anytime a coordinate's on an axis, one of the numbers is always 1. If you want to label a coordinate on an x or y axis. It's what? 0. Yeah, one of the coordinates always has a 0 in it somewhere. All right, so let's start with, let's just do 90 degrees. Okay, see if we can get the coordinate for that one. So for 90 degrees, all you've done is go up 1 unit. Okay, starting at the origin. I know it's 1 unit because that's the radius of the circle. So what would be the coordinate if you just went up 1 unit? Not 1, 0. We're going to do that for something else. So that's going to come up though.
0.
Yep, the coordinate for 90 degrees is 0, 1. That's always the coordinate. That never changes for the entire week. Right. How about the coordinate for 180 degrees? Yeah.
-1, 0.
Yep, -1, 0. And the coordinate for, let's do 270. How about, Megan, could you tell me the coordinate for 270?
0, -1.
Yep, 0, -1. Okay, and I think Isaiah said this one earlier. The coordinate for 0 degrees, which is also the same as 360, is 1, 0. Okay, so that's 4 coordinates that now we know or 4 angles that we know the coordinates for. Any questions on how we got those 4? Okay, those are the easiest ones, and those are the ones that have the nicest numbers in them. Okay, all the other ones are going to have fractions, and some are going to have square roots. Now, it says here, every angle. Well, we're not really going to be able to do every angle. We're really just going to be doing angles that are multiples of 30 and 45. So like 30, 60, 90, 120, 150. And there's some overlap there, because obviously 90 is a multiple of both. So when I say every angle, I really mean multiples of 30 and 45. Now, technically, you can do multiples of 15, and if you can do 15, then you can do 7.5. There's all kinds of like fancy formulas, but really, we're focusing on 30s and 45s. Okay, so just a reminder about which way is positive and which way is negative. So, if you go counterclockwise, that's positive. Clockwise is negative. Now, given the choice, if we could just choose, like, all right, you're going to work with negative or positive, which one do you think is easier? Yeah, positive. I would go with positive if you can. Right, so let me bring up the that circle where I can draw angles on the board. I'm going to bring that up so we can look at a couple things. Okay, so let's take a look at this. So remember, as you draw counterclockwise, you can see your angle getting positive. There's a top number and the bottom number. What unit is the top number using? Degrees. And the bottom one doesn't have a label, so what's it using? Yeah, it's using radians. All right. So as we go around, we go 360. Oops. Then we go more than 360. That's fine. You just get an angle that's bigger than 360, more than one revolution. All right, we go back the other way. Okay, going clockwise, now we get negative angle. So, let's put that here. So, that's a 90-degree angle. Right? And what did we say the coordinate was for 90 on the unit circle? 0, 1. Yep. So, just focus on where the red little circle thing is, on the edge of this black circle. Okay, so it's at the top. Where is the red circle now?
Still 0, 1.
Still 0, 1, right? I mean, our coordinate grid here is a little different. Maybe each tick mark is like a quarter unit or something, but that's fine. Now, what's the angle this time? Doesn't say 90 anymore. Negative 270. So that tells you if this red circle thing is in the same spot, 90 and negative 270 are the same thing. Right? For the purposes of doing trig, those two angles are the same number. Okay? Because they have the same coordinate on the unit circle. So how would you get from negative 270 to 90? Think about like what I'm doing right here, but I want to think about it in terms of arithmetic. What did I just do to negative 270? Yeah.
Added 360.
All I did was add 360 to it. Okay. Brought the circle around one time and added 360. So, anytime we have an angle that's either too big or too small, that's going to be the key. It's going to be adding or subtracting 360. So, if we have an angle that's too big, it could look something like that. Okay. I tried to put it on 450, close enough. 450, kind of a big angle. It can be hard to think about. Okay. It's like 450. I'm not really sure how big that is. Well, we can make it smaller just by subtracting 360 degrees. Okay. Unit circle trig doesn't care about how many times you go around. All it cares about is where did you stop? What's the coordinate for where you stopped? All right. So, if we have an angle that's greater than 360, or even greater than or equal to, okay, that's too big. It's hard to think about. So we're going to make it smaller. How do we make it smaller? We subtract 360. And now you don't have to actually draw that. You can just use your calculator. Just take your angle minus 360. Now, you don't want to keep subtracting 360 too many times. Because what would happen if you subtract 360 too many times from your angle? Oh, Andrew, can we guess what would happen if you subtracted 360 too many times? What's eventually going to happen if you started out with an angle that's pretty big and you keep subtracting 360 from it? Or take any number and just keep subtracting 360 over and over.
Well, it's going to get really deep into negatives.
Yeah, and we don't want it negative. So you only want to subtract 360 as much as you need to. All right? So only do it until you get an answer between 0 and 360. All right, so let's say I was working with a 2,500 degree angle. Way too big. All right, I'm trying to, first thing I got to do with unit circle trig is figure out the coordinate for 2,500 degrees. That's a really hard number to think about. Make it smaller. Still too big. Make it smaller again. Keep going until you get an angle that's more manageable. Okay, 340 degrees, that I can kind of visualize. I say, all right, well, 360 is almost all the way around. So 340 is just a little bit shy of all the way around the circle. Just a little bit. Okay? And then we'd have to figure out the coordinate for that. Now, 340, that's not a multiple of 30. It's like asking if 34 is a multiple of 3. No. So that's not one we'd be able to do. But the idea is still the same. You subtract 360 till you get it smaller. Okay, and now I also said this one earlier. Cal, if you got an angle that's negative, it's kind of hard to think about, like negative 10,000 degrees. What can you add as many times as you need to make it positive?
360 degrees.
Yeah, exactly. And the reason you can add or subtract 360 is because it brings you to the exact same point on the circle again. Brings you right back where you started, basically. It just takes away or adds revolutions, but you're never changing the coordinate. Okay, so any questions on that idea? Okay, this adding and subtracting 360 is purely for us. Okay? It just makes it easier for us to draw the angle on the circle. Okay? If you tell me 3,000 degrees, I'm like, that's way too many times around. I can't figure that out. So I'm going to make it smaller. All right, so we're going to look at the 6 trig functions. And I'm going to give you the definitions of them. And they're going to be based on the unit circle coordinate. So if you've done like opposite, adjacent, and hypotenuse, yep, that's one way you can do it. And we're gonna do that next week. This week, it's all going to be based off a coordinate. So a coordinate has 2 values. Okay? It's got an x and it's got a y. If you can find those 2 numbers, the x and the y, you can do all 6 of these. All right. Can anybody name one of the 6 trig functions? I think they can name. Division?
Sure.
Did someone say division?
I said addition.
Oh, addition. Addition is it is an operation, but not trig. So we're thinking there's special buttons for these on the calculator. Well, there's buttons for addition too. But the buttons for these on the calculators are usually abbreviated with three letters. Yep.
Cosine.
Cosine. Yep. So that one's abbreviated COS on the calculator. Does anyone know another one? Cosine. Yep. Tangent. And there's one more basic one. cosine, tangent, and
Sine.
yeah, very good. So sine, cosine, and tangent. Those are the first three. And honestly, those are the three that we use the most often. The other three, there actually aren't buttons for it on your calculator because they're not used as much. So I'll show you how you would do it on the calculator if you needed to. All right. So again, the following definitions, you have to figure out the coordinate. If you can't figure out the coordinate that I've showed you guys, then you can't do unit circle trig. That's the first step. Gotta get the coordinate. And once you have the coordinate, if the problem asked you about the sine, the answer is the y value of your coordinate.
Why do you have a theta sign?
So remember, what is theta? What do the Greek letters usually represent in trig? Yeah, angles. So this would be theta right there. It would represent this angle. So if I said to you, what's the sine of this angle? You'd see the question written like this. Except you'd actually know what theta is. You'd be given a number. Like, I'll just show you an example of what the problem would look like. I may say, find the sine of 90 degrees, cosine of 90. So you'll have a number filled in there. All right. So to find the sine of whatever they ask you to find, 90, 30, 60, all you have to do is figure out your coordinate and then write down the y value. To find the cosine of whatever angle they ask you about, find the coordinate and write down the x value. Sine and cosine are the easiest two because all they do is use the coordinate. You don't have to do any arithmetic. One's the y, one's the x. To find the tangent, you need both the y and the x, and you divide them. So if you've done opposite, adjacent, opposite over hypotenuse, stuff like that, this is the same thing. All right. Any questions on those first three? All right. So, second three. Second three, we don't see them as much. You don't have a button for them. Doesn't mean you can't do them on the calculator. But it's the cosecant, the secant, and the cotangent. And I wrote them the way I did in 3 rows on purpose. Okay, so there's a reason I have sine across from cosecant, cosine secant, tangent cotangent. There's a special connection between them. Okay, I'm going to show you the first one, and I think once I show you that one, you'll be able to figure out the other two. Now, right now, let's look at sine. Sine's not a fraction, but we could make it a fraction by putting it over what number? Right, we could put it over 1. Now, if you flip y over 1, what do you get? You get 1 over y, and that's called the cosecant. I normally won't write this as y over 1. I just did that to show you. And what's that fancy name when you flip a fraction? Reciprocal. So these two functions are what we call reciprocals of each other. If one of them gives you 2, the other one's going to give you 1/2. If one of them gave you 3, the other one will give you 1/3. Okay? They're reciprocals. So once you know one, you really know the other one. Pretty much, it's automatic. Now, these are all reciprocals, the ones that are directly across from each other in the same row. So the cosine is x. What do you think the secant is going to be?
1 over x.
Yep, it's going to be 1 over x. And how about the cotangent?
Y times x.
X over
X over y.
Oh.
Yeah, just flip it. Right, just flip it.
Oh, I thought that was like dividing. That one.
Yep, so this one is dividing, and when you flip it, it's still dividing.
Oh.
Yep, technically these are all dividing if you want to think of them like that. Any questions on those 6 definitions? All right, now these 4 angles, 0, 90, 180, 270, they have a special name because they're on the axes. When you draw your axes, it divides your plane into 4, what do we call those sections?
Plane.
The plane, yeah, when you divide it in, put the axes, it divides it into 4 quadrants, yep. So these are called quadrantal angles because they're the angles that are right on the edges of all the quadrants. And for today, those are the only angles we're going to work with. Okay? I told you eventually we're going to work with angles that are multiples of 30 and 45. That's not going to be until tomorrow and Wednesday. All right, so now I'm going to explain to you the 2 steps to do unit circle trig. All right, but to kind of quickly summarize them, the first step is figure out a coordinate, and the second step is plug it into one of these formulas. Which one? Whichever one they ask you for. Okay. We're going to practice all 6 in class. Okay. But on a test, I'll only ask you one of these functions per problem. Like maybe question 1 on the test will be about sine. Question 2 will be about secant. Question 3 will be about tangent. Okay. We're not going to do all 6 like this in the same problem on the test. All right. But to practice, we'll try all 6. All right. So step 1, that's what I just said to you. Find the coordinate on the unit circle. Okay. Remember, every angle on the unit circle can be represented as a coordinate. You have to figure out the coordinate that represents the angle that I give you. So if I give you 90, you've got to think in your head, okay, what's the coordinate for 90? And if I give you 180, you have to think, okay, bless you. What's the coordinate for 180? Okay, you've got to find the coordinate that corresponds to the angle that I give you. Now, sometimes I will give you the coordinate. I'll do step 1 for you. Okay, if I do step 1 for you, you don't have to worry about it. You'll already have the coordinate. And the reason I might do step 1 for you today is because so far you guys can't work with very many coordinates. All you know is like 0, 1, 1, 0, negative 1, 0, 0, negative 1. Those are the only 4 coordinates you guys have for the 0, the 90, the 180, and the 270. Well, I want you to be able to work with other coordinates. So if it's a coordinate I haven't taught you how to figure out yet, I'll just give it to you. Okay? Like this one we're going to do in a few minutes. I'm not going to do it yet. Okay? But that's a coordinate. You don't know how to get that one yet. So I'm just going to give it to you. And then we'll practice using that coordinate to do step 2, which is take the coordinate that I either gave you or you figured out yourself, and take the definitions that I gave you on the other page, all 6 of them, and fill in the coordinate to all 6. Fill in all the x and the y values. Okay, now remember, we're going to have lots of fractions. You can't leave a square root in the bottom. Okay, so if you get a square root, don't leave it in the bottom. And if you get a square root that can be simplified, you have to simplify it. That's not going to happen much today. Okay. The 2 square roots you're going to see a lot. A square root of 2, square root of 3. You can't simplify the square root of 2 or the square root of 3. They're already simplified. Okay. Okay, so again, step 1, figure out the coordinate. Step 2, plug it into the formulas that I just gave you. Let's try some examples. That's example 1. So here's your coordinate. Okay. You don't have to find it this time. I'm giving it to you. Now, does that look like the coordinate for 0, 90, 180, or 270? No, it's not. So the coordinate, if it was for 0, 90, 180, or 270, it would look something like 0, 1, 1, 0, negative 1, 0. This has square roots and fractions in it. So it's the coordinate for something. What is it the coordinate for? You don't need to know for this problem. Okay? Doesn't matter what it's the coordinate for. All that matters is you have it, and now we use it. Okay? By tomorrow or Wednesday, you'll know what that is the coordinate for. Okay? It is an angle that's a multiple of 30. Okay? So that coordinate, I'm just calling it point P. It's a point somewhere on the unit circle. And that point represents some angle. All that I'm interested in is finding the 6 trig functions of that angle. So at first, some people get a little confused because they're like, well, how can you find the trig functions of that angle when you don't even know what the angle is you're working with? And you're never going to know what the angle is in this problem. And it's kind of like if you saw somebody that you didn't know, you don't know their name, and describing a bunch of things about them. I don't need to know your name to look at you and say what color shirt you're wearing, what color eyes you have, how tall you are. I can describe things about you without knowing your name. Well, you can describe the trig functions of this angle without ever knowing how big it is. It's the same idea. You don't need to know that to describe it. Okay? So what I usually do is I set up all 6 trig functions, just kind of like that. Sine, cosine, tangent down one side, cosecant, secant, cotangent down the other. Okay, and we'll start with sine. So Brianna, do you have or you remember what the formula for sine was? It said sine equals y. So we go up and look at our coordinate. And Sebastian, what's the y value in my coordinate?
Wouldn't it be 2? Or is it -1?
So here's your coordinate you're looking at right there. So you're looking for, does the y value come first or second?
First. Or second.
Second.
Sorry, I'm having a rough day.
It's all right. So just remember alphabetical order, x before y. So we got the x value first, y value second. What's the y value
It
there?
would be the square root of 3 over 2.
Yeah, square root of 3 over 2. And that's it. That's the sine of my angle. What's my angle? We don't know. Okay. Now what would you use that for? We'll see that later on, but you could use this number to do something. But that's the sine of the angle, square root of 3 over 2. Courtney, what was my formula for cosine?
X.
Cosine equals x. And how about Cal, what's my x value here?
-1/2.
That's it. So those are the easiest two because we don't have to We don't have to do, like these other ones, we're gonna have to do reciprocal. So we're gonna have to flip things, but we don't have to worry about that yet. Matt, what was my formula for tangent?
It's y over x.
Y over x. So y, well, we got them right here. Y, x. So y is the square root of 3 over 2. Doing this off to the side because I'm going to need a little space to do some work, and then I'll put my final answer next to tangent. So y over x. Now, first thing, we're dividing two fractions, and they have the same denominators. What happens to the 2's? When we divide two fractions, and we get the same denominator. They cancel out. Some people like to flip. Like when you divide two fractions, they do something like this. Take the 1 in the bottom, flip it, and multiply by the 1 in the top. I mean, you can, if you want to write it that way, you can. But the 2's are just going to end up canceling out. So I don't even flip it and multiply. I just go like this. 2, 2. Those are gone. And all we're left with is the square root of 3 divided by negative 1, which is the negative square root of 3. And that's my tangent. Okay, any questions how I figured out my sine, my cosine, or my tangent? All right, so Anthony, once I know the 3 on the left, and I asked what was that fancy word that we used for flipping the fraction? What, do you remember what it was? Reciprocal. So all we have to do now is take the 3 on the left, flip them, find the reciprocal, and that's the answers to the 3 on the right.
Right.
So let's start with cosecant. Justin, when I started, I take square root of 3 over 2, flip it, and what does that give me?
2 over square root of 3.
Yep, gives me 2 over square root of 3. Now that's something I talked about. Emily, what's wrong with that?
Which one?
Cosecant.
Oh, I thought you were trying to hurt. Well, you have to multiply it like the square root on the top too.
Right, we can't leave that square root in the bottom. And how did you say to fix it?
To multiply it on the top.
Top and bottom. So multiply top and bottom by square root of 3. And Abby, when I multiply, what's that going to give me in the top?
2 square roots.
Yeah, 2 square roots of 3. You can't really do anything with the top. But the bottom is the square root of 3 times the square root of 3, which is the square root of 9. Which the square root of 9 is 3. Perfect. And that is the cosecant. The cosecant of my specific angle. Which again, we don't know what the angle is. But that's fine, we don't need to. How about the secant? Anyone think they could give me that one? There's no square root there, so that one's going to be a little quicker. Yeah, Anthony?
Would it be negative 2 over 1?
Yep. So you're going to flip it. Still stays negative. If you want to leave it as negative 2 over 1, you can, but you could just put negative 2. Right, so we flipped it, and now for the cotangent, I don't have anything to flip. So Gabe, what could I do to make the tangent into something I could flip?
Put it over 1.
Yeah, we could just put it over 1. I mean, if you can do that in your head, you don't need to, but just put it over 1. And now, Megan, when I flip that, don't worry about what happens to the square root, but can you just tell me what I get when I flip the tangent?
1 over the square root of 3. Negative 3.
Can you say it one more time?
1 over the negative square root of 3.
Yep. And whether you put the negative in the top or the bottom, it doesn't matter, as long as you keep it negative. And now we got to fix this one the same way Abby fixed the cosecant. So Riley, how do I fix having that square root of 3 in the bottom?
You have to multiply the square root of 3 on the top and bottom.
All right, so multiply. Okay, in the top, just multiply straight across. So how about Alex, when I go straight across the top, what do I get?
Square
Careful, not quite. That negative, this is not under a root. If you had that, I would say yes, it would be the square root of -3. Yep.
-1 square root of 3 over square root of 9.
Right, so it's just negative square root of 3. That negative stays on the outside, okay? It doesn't go inside. Think if you put it inside, now you'd have the square root of a negative number, and now it's imaginary. So now it's, and we're not doing anything with imaginaries this week. Right? And Isaiah, you said in the bottom square root of 9, which is 3. Perfect. Okay, so that's the 6 trig functions for that coordinate, which represents some angle somewhere on the unit circle. Okay. So that would be 6 problems on a test. 6 separate problems. Okay, but I'm probably not going to give you the same coordinate and have you do it 6 times. I'll give you a coordinate and I'll say, okay, just find the sign of this coordinate. And then I'll give you a different coordinate and I'll say, find the secant. Okay, so I'm gonna switch the coordinate, not use the same one 6 times. Okay. Any questions on that? All right. Let's try this one. So find the 6 trig functions of, and the coordinate is square root of 2 over 2, comma square root of 2 over 2. Now, does that coordinate look anything like the coordinate for 0, 90, 180, or 270? No. Coordinate for those didn't have any square roots or fractions in them. Now, you don't need to know this yet, but does anyone think they know what that is the coordinate for? What angle? The x and the y are the same. So think about on the circle, if you start at the origin and you go right and up, it's exactly the same amount. You're in quadrant 1, positive, positive. So your angle is somewhere between 0 and 90. Yeah?
45 degrees.
Yeah, it is. That's the coordinate for a 45-degree angle. Okay? You don't need to know that for this problem to do the problem, but it is. Okay? It's the coordinate for a 45-degree angle. So now, what we're really doing is finding all 6 trig functions for a 45-degree angle. But we're going to pretend we don't know it's a 45-degree angle. Right, so let's start with the sign. Okay, Brandon, what would be my sign in this problem?
Square root of 2 over 2.
Yep, and just so I know, which one did you pick? The first one or the second one?
Second.
Yes, the second one. That's your y value. Okay, so we've got our sign. Grace, how about the cosine?
First, square root of 2 over 2.
Yep. Just a coincidence in this problem, they're the same. So if you mix them up, you'd be okay. But in general, don't mix them up. Okay. And now tangent. Remember, tangent is y divided by x. But y and x are the same. So what are we going to get there? 1. I mean, you can go through and you can set it up and cancel everything out, but you're just dividing 2 things that are the same. Okay? So sometimes what I do is, if I find an easy one, I do that one first. So let's do the cotangent. If you take 1 and you flip it, what do you get? It stays the same. Think of it as 1 over 1, and you're flipping it, and it stays 1 over 1. So that one stays the same. Now, what's nice about the cosecant and secant is once we figure out one of them, we have the other one automatically. Okay? Because the sine and the cosine are the same. So really, we only have one more calculation, and we're done. So Jason, once I have the one on the left, what do I always do with it to get the one on the right?
Multiply by the reciprocal.
Or
Or not multiply, but.
not multiply, just
flip
flip it. Yeah, just reciprocal. So let's do that. Okay, so I got the reciprocal. And Malika, now that I've got that, is that okay for my final answer? No. What do I have to do to fix that? Yep, multiply by square root of 2. Okay. And in the top, Emily, what will I have when I multiply straight across?
2 times square root of 2 over 2.
Yep. Now, look what happened there. 2, square root of 2 over 2. What can I do? There's one more, just the way the numbers worked out.
You got the two.
You can cross the 2's out on the outside. Because you're taking the square root of 2 in the top and doubling it, and then you're going to divide it by 2. So that cancels out. So the cosecant is the square root of 2. And Elizabeth, now we should be able to get the secant quickly. What would that be?
The same answer.
It's the same. Okay. So there's all 6 trig functions for the coordinate for 45 degrees. But you don't need to know that. Square root of 2 over 2, comma root 2 over 2. Okay. Any question on that? Okay, so we've done 2 of that type. Anyone think they need I have a third one. Anyone need a third one of doing that kind of thing? The hardest thing that comes up is just dealing with the square roots. Okay. Alright, let's do this one. Find the 6 trig functions for 90 degrees. What's different about this problem? Yeah.
It's in degrees, so you have to find the coordinates.
Right.
It's at an angle.
Yep, the fact that they've given me the angle, that's not really directly helpful. I need the coordinate for that. So now we have to figure that out first, and then we can do all this stuff. What I usually do for 0, 90, 180, 270, just kind of visualize where 90 would be, and then just write down your coordinate. There's no calculation to do for 0, 90, 180, 270. So Elizabeth, yeah, were you going to
0, 1.
say the coordinate? 0, 1. Now we've got the x, we've got the y. Fill them in just like every other problem. Right, so Pat, could you tell me my sine of 90 degrees?
1.
Yep, it's 1. And Yoshira, my cosine? 0. Right, now let's set this up first, and then we'll see if we get it right. Tangent is y over x. So Alyssa, what would be my fraction right here?
0 over 1.
No, that's x over y.
1 over 0.
1 over 0. Okay, 1 over 0. What is 1 divided by 0?
0.
No.
What?
Is it undefined?
Undefined. Yes. You can't do that. The way I remember you can't do that is if you take a number and you divide by 0, it spells no. You can't do a number divided by 0. Number divided by 0? No. Can't do it. Right? If you try it on your calculator, it'll probably just say you can't divide by 0 or something like that. I cleared it, but yeah, can't divide by 0. All right, so can't divide by 0. All right, my cosecant. Andrew, what's my cosecant?
Just 1.
Yeah, if you want to think of 1 as a fraction, flip it, and you're going to get 1. All right, how about my secant? If you want to think of it as a fraction, put it like that. You don't think they can tell me what my secant's going to be? Yep.
Yeah, undefined.
It's undefined. When you flip it, it's 1 divided by 0. We just did that. Undefined. Now, for the cotangent, you're flipping undefined. Or what you're really flipping is 1 divided by 0. So flip it. What's 0 divided by 1? 0, yes. All right, so if you get to this point, like you write 0 divided by 1 and then you put undefined or something, like you mess up because you forget what 0 divided by 1 is, you're going to lose the points for it. Okay, so you got to know 1 divided by 0 versus 0 divided by 1. Okay. Number divided by 0? No, can't do it. 0 divided by a number? On. Just go with a number divided by 0. It's no. Any questions on that? All right. This one, it's not asking you for all 6. It's only asking for the first 3. Find the sine, the cosine, and the tangent of 3 pi. It's kind of like the last one, but what's a little different about this one? It's almost like there's one more step this time.
Do you have to flip from radians to degrees?
Yeah, a lot of people find it easier to work with degrees. So if you can't visualize 3 pi in your head, then yes, I would change it to degrees first. Okay, to change from degrees to radians, what do we multiply by?
180.
180. And what do we divide by? Pi. Yep. So 180 over pi. Pi's are going to cancel. And what's 180 times 3? Or just think of 18 times 3 and put a 0.
54.
Yep, so 540. Okay, so we got 540 degrees. So I like it better because it's now in degrees, but I still don't like that angle. What do you think I don't like about 540 degrees?
It's over 360.
It's over 360, so now you're trying to visualize going around more than one time. Well, we can make that easier to work with by doing what to it?
Minus 360.
Yep, minus 360. And we're going to hope that it comes out to a coordinate that, or an angle that we know the coordinate for. 180. So 3 pi is really just 180. All right, so I've done as much as I can to make that angle as easy as possible to work with. What do I have to do at this point? If you can't do this, you're stuck now.
You get the coordinates of 180.
You've got to figure out the coordinate for 180. Yep.
1, 0.
Where's 180 on that circle?
Left side.
Left side.
Negative 1.
Negative 1, 0. Now we can fill everything in. Okay. So my sine is going to be how much? 0. My cosine? Negative 1. And, bless you, my tangent. 0, right? Tangent is y divided by x. 0 in the top is okay. All right? 0 in the top is okay. If you divide $0 to anything, like $0 divided to 5 people, everybody gets 0. Any question on that one? All right, I think we got one more, and I'll let you guys take a couple minutes and try that one. Okay, so find the 6 trig functions of 11 pi over 2. Now, they didn't give you the coordinate, so it's got to come out to 0, 90, 180, or 270. It has to be, because I haven't taught you how to find the other coordinates yet. So it's going to come out to one of those. Okay, so take a couple minutes. If you get stuck, just call me over. I'll help you out, and then we'll finish this one up, and that'll be it. All right, so let's take a look at this. So what's the first thing that most people did here? Okay, I think, yeah, we should change from radians to degrees. So multiply by 180 over pi. If you want to reduce, you can. 2 goes in once, and 2 goes in to 180 90 times. And what's 90 times 11? 990. Okay. So now we still want to do a little bit more with that. Okay, off the top of my head, 990. I'm not sure what the coordinate is for 990. But I can find what it's the same as by doing what? Yeah, just subtract 360. So let's take 990. So it's the same as the coordinate for 630. Still not sure. Let's subtract 360 again. 270. All right. So if I draw my unit circle, where's 270? Yep, it's at the bottom. And what's the coordinate if you go straight down? 0, -1. Now we're good to fill out all those 6 formulas. Let's start with my sine, Isaiah. What's the sine? Yep. And your share on my cosine? 0? Okay. My tangent. What's my tangent? Yes. Yes, undefined. It's -1 divided by 0. So it's undefined. Means you can't do it. My cosecant, how about Pat?
-1.
Perfect. Take -1 and flip it. It's still 1 over -1, so it stays the same. My secant, what's that going to be? Undefined, because it's like you're flipping 0 over 1. So it turns into 1 over 0. So when you flip 0, you get undefined. When you flip undefined, you get, there you go. Yeah.
Do you always have to write like the 11 pi over 2 after like your sine, cosine? Or can you just write sine equals -1? Cosine equals 0.
You could write sine, that's okay, yeah.
I just,
It would be okay. Yeah.
Maybe it should be entire.
For what we're doing, I would know what you're talking about. But if you were going to type something in on a calculator, whenever you press sine, you have to put something after it. Like if you just hit sine and you don't put anything, it doesn't know what it is. So you're supposed to, but that's okay. Okay, so homework. It's on 116. 11 to 27, just the odds. And 22 is the only even question that I could do. So you got a little under 15 minutes left. Okay, so if you want to use the time, you got a little bit of time to start. If you get stuck, if you need help, just let me know. Yes.
Can you say what